You've watched flames dance a million times, birthday candles, bonfires on summer nights, gas stoves clicking to life. Fire is everywhere, so familiar that it barely registers as strange anymore. But here's what nobody tells you. You have absolutely no idea what fire actually is. Most people think they do. Fire is hot. Fire burns things. Fire is dangerous. That's not understanding. That's observation. That's like saying the ocean is wet and thinking you've explained fluid dynamics. When you actually investigate what's happening when something burns, when you peer behind the curtain at the atomic choreography unfolding in every flame, you discover something so profoundly interconnected, so elegantly violent, that it rewires your understanding of existence itself. Fire isn't just a phenomenon. Fire is a revelation about energy, atoms, sunlight, and why the air you're breathing right now exists at all. Let me tear apart everything you thought you knew. Take a log. Dead wood, inert, sitting in your fireplace. Take air, specifically the oxygen floating invisibly around that log. The wood has been there, the oxygen has been there, they're in the same space, touching constantly. Nothing happens, days pass, weeks, years. The wood and oxygen remain separate, unchanged, coexisting peacefully like strangers on a subway platform who'll never speak. But here's the secret. At the atomic level, they're desperate for each other. Carbon atoms in the wood and oxygen molecules in the air have a magnetic attraction. If they could get close enough, if they could overcome their mutual standoff, they'd snap together with explosive enthusiasm, releasing enormous energy. This is the arrangement nature prefers. Carbon and oxygen bonded together as carbon dioxide. It's the stable configuration, the low energy state, the atomic equivalent of lovers finally embracing after years of separation. So why don't they? Why doesn't wood spontaneously explode into flame the moment oxygen touches it? Because there's a wall between them, an energy barrier. Imagine rolling a marble toward a volcano crater. If you roll it gently, it approaches the crater's edge, starts climbing the lip, then rolls backward. It wants to fall into that deep crater. That's the lowest energy position available, but it can't get over the edge. It doesn't have enough momentum. Roll after roll, it approaches and retreats, never falling in. That's wood and oxygen. Every second, trillions of oxygen molecules are colliding with carbon atoms in the wood, bouncing off, separating, colliding again. Nothing happens. The atoms lack sufficient energy to climb over that initial barrier. They hit each other like cars in slow motion, touching, separating, no damage done. This standoff can persist indefinitely. Archaeologists have found wooden artifacts thousands of years old. The wood was surrounded by oxygen that entire time. Every second of every day for millennia, oxygen molecules bombarded those carbon atoms. Trillions upon trillions of collisions. Zero reactions. The atoms wanted to bond. The barrier prevented it. The wood remained wood. The oxygen remained oxygen. Stalemate. But then you introduce heat, a match, a spark, a concentrated burst of energy. Suddenly, a few atoms in a tiny region start moving faster, jiggling more violently. This is what heat actually is. Atomic motion. Temperature isn't a substance that flows into objects like water into a cup. Temperature is speed. Hot atoms are fast atoms, vibrating intensely. Cold atoms are slow atoms, barely moving. When you heat wood with a match, you're making atoms in that small area jiggle faster and faster until some of them, just a handful initially, jiggle fast enough to overcome the barrier. They slam into oxygen molecules with sufficient force to get over that energy wall. And when they do, they snap together. Carbon and oxygen finally unite. That union releases energy, a lot of energy. That released energy makes surrounding atoms jiggle even faster. Those atoms now have enough speed to overcome the barrier. They react, release more energy. make more atoms move faster. Those atoms react, release more energy. You see the pattern? It's exponential growth. One reaction triggers 2, 2 trigger 4, 4 trigger 16, 16 trigger 256. Within fractions of a second, you've gone from a handful of reactions to billions of simultaneous atomic unions. This isn't gradual, it's explosive. It's a chain reaction, a runaway cascade, a feedback loop feeding on itself. That cascade has a name, fire. Fire is not an object. It's not a thing you can hold or isolate. Fire is a process, a catastrophic avalanche of atoms snapping together faster than the mind can track each reaction, fueling countless others, heat generating more heat, reactions triggering more reactions. It's a self-perpetuating storm of atomic activity. The energy released doesn't vanish. It becomes motion, atoms vibrating wildly, electrons jumping to higher energy states, then crashing back down, releasing photons as they fall. That's the light you see, the flames, the glow. Different elements produce different colored light when their electrons make these jumps. Sodium yellow, copper green, potassium violet. That's why fireworks exist. Different chemicals, different colors. The heat you feel when you approach fire, that's infrared photons bombarding your skin, making your atoms jiggle faster, heat transferring as radiation. And here's the crucial insight. Once this process begins, it sustains itself. The heat from reactions provides the energy needed to initiate more reactions. The reactions produce more heat. The heat enables more reactions. Fire spreads because it creates its own fuel, not physical fuel, but energy fuel. It manufactures the conditions needed for its own continuation. That's why fire is so dangerous, why it's so hard to stop once it starts. You're fighting a self-reinforcing cycle. The only way to stop fire is to break the cycle, cool it below the threshold temperature so atoms stop moving fast enough to react. Remove the fuel so there's nothing left to react. Remove the oxygen so the carbon has nothing to bond with. Break any leg of that triangle and the process collapses instantly. But let's zoom out. Let's ask the next question. The one that transforms this from chemistry lesson to cosmic revelation. Where did the wood come from? Trees, obviously. And where did the tree's mass come from? This is where people get it spectacularly wrong. Everyone, and I mean everyone, thinks trees grow from the ground. You plant seeds in soil, roots dig down, the tree grows, therefore the tree came from the soil, right? Wrong. Completely, totally, magnificently wrong. Here's an experiment anyone can do. Take a pot of soil, weigh it precisely, plant a seed, water it regularly for years, let the tree grow massive, hundreds of pounds of wood, branches, leaves. Now uproot the tree and weigh the soil again, you'll discover something shocking. The soil weighs almost exactly what it weighed before, maybe a few ounces lighter. Some minerals got absorbed, but the tree weighs hundreds of pounds more than it did as a seed. Where did that mass come from? Not from the soil. The soil didn't lose hundreds of pounds. This experiment was performed in the 1600s by Jan Baptist van Helmont, a Dutch scientist genuinely trying to understand plant growth. He documented everything meticulously. The soil barely changed weight. The tree gained enormous weight. His conclusion, the tree didn't come from the soil. Van Helmont thought it came from water. Close but not quite. The truth is even more beautiful. The tree came from air. Specifically from carbon dioxide. The carbon in CO2 is what the tree builds itself from. Carbon dioxide floats invisibly around the tree. The tree sucks it in. Through the absolute miracle of photosynthesis, it tears that molecule apart, ripping the carbon away from the oxygen, keeping the carbon, spitting the oxygen back out. It combines that carbon with water from the soil and constructs itself cellulose, lignin, all the complex molecules that make wood, Their carbon chains assembled atom by atom from carbon dioxide in the atmosphere. This is not a metaphor. This is literal. Trees are solidified air. People find this impossible to believe. How can something solid come from something invisible? How can mass materialize from gas? But do the math. A mature oak tree contains roughly half a ton of carbon. That carbon was atmospheric CO2. The tree grabbed it molecule by molecule, photon by photon, building itself from sky. The small amount of minerals trees pull from soil, the iron, the magnesium, the trace elements, those become the ash when you burn wood. A tiny residue left after fire consumes everything else that came from earth, but the wood itself, the bulk mass, sky. Which leads to the next question. How does a tree perform this magic? How does it tear apart carbon dioxide, which is extremely stable, which is what carbon and oxygen become when they want to be together? If carbon and oxygen naturally snap together with such force that they create fire, how does a tree undo that bond? The answer: sunlight. The sun is constantly bombarding Earth with photons, particles of light, packets of pure energy. When those photons hit leaves, they get absorbed by chlorophyll molecules. That energy doesn't disappear. It gets used to do work. Specifically, it gets used to force carbon dioxide molecules apart against their will. The tree is using light as a crowbar to pry carbon away from oxygen. This requires energy because you're pushing the system uphill away from its preferred state. You're separating lovers who want to embrace. You're rolling that marble back up out of the volcano crater. It takes force. It takes work. And the sun provides that work. So the tree spends all day, every day, absorbing sunlight and using that energy to build structure. It's pulling carbon from air and arranging it into solid form. It's storing energy in the separation between carbon and oxygen. Those atoms want to be together. The tree is holding them apart. That separation is potential energy. Like lifting a boulder to the top of a hill, you've done work, and that work is stored as gravitational potential energy. The tree does work, and that work is stored as chemical potential energy in the bonds of complex molecules. And then you cut the tree down. You stack the wood in your fireplace. You light it, and everything the tree built gets undone. The carbon and oxygen, held apart for decades, finally get to snap back together. The energy the tree stored by separating them comes flooding out as they reunite. The light you see in the flames, that's sunlight. Stored sunlight from years ago, released in seconds. Every photon flickering in your fireplace is recycled solar energy. The tree spent summers, maybe decades of summers, collecting sunlight photon by photon, storing it bit by bit in its structure. You're liberating that stored energy all at once. Fire is collapse time. It's compressed summers exploding back into light and heat. Think about that. Really think about it. The warmth on your face from a campfire is the same warmth that fell on leaves 10 years ago, 20 years ago, captured and held, now escaping. The carbon dioxide rising from the fire is the exact same CO2 the tree inhaled decades earlier, now exhaled back into atmosphere. You're witnessing a cycle complete itself. The carbon that the tree worked so hard to extract from air is returning to air. The oxygen the tree released as waste is recombining with that carbon. The energy the sun injected is being released. It's all undoing itself, returning to equilibrium. And here's where it gets even more profound. That oxygen in the air, where did it come from? From trees, from plants, from billions of years of photosynthesis. Earth's early atmosphere contained almost no free oxygen. It was mostly carbon dioxide and nitrogen. Then photosynthetic organisms evolved, cyanobacteria, algae, eventually plants. They started doing what the tree in your yard does, ripping apart CO2, keeping the carbon, dumping the oxygen. For them, oxygen was waste, poison actually. Many early organisms couldn't tolerate oxygen. When oxygen levels rose, an event called the Great Oxidation Event roughly 2.5 billion years ago, it caused a mass extinction. Organisms adapted to an oxygen-free world died out. But some organisms evolved to exploit this waste product. They developed cellular machinery to use oxygen to burn fuel, to combine oxygen with carbon-based molecules and extract energy from that reaction. Those organisms thrived. They could extract far more energy from food than organisms relying on other methods. And eventually they evolved into everything you see. Animals, fungi, complex multicellular life, all of it powered by burning carbon with oxygen. You are burning carbon with oxygen right now. Inside every cell in your body, mitochondria are combining glucose with oxygen, producing carbon dioxide and water, releasing energy. It's the same reaction as fire, same chemistry, same products, same energy release. The only difference is speed and control. Your cells do it gradually, capturing the energy in usable molecules like ATP. Fire does it all at once, releasing energy as light and heat. You are a slow fire. Your metabolism is controlled combustion. Every breath you take brings in oxygen to burn the carbon-based food you ate. Every breath you exhale releases carbon dioxide, the combustion byproduct. You're not different from fire. You're just fire that learned to happen slowly enough to build complex structures before burning out. Life is controlled burning. Aging is oxidation, rust, decay, metabolism, all variations on the same theme, carbon and oxygen finding each other, which brings us full circle. The sun shines. Plants use that light to tear apart carbon dioxide, building themselves from carbon, releasing oxygen. Animals eat the plants, or eat animals that ate plants, and burn that carbon with oxygen to release energy. The CO2 we exhale is the same CO2 plants inhale. The oxygen plants release is the same oxygen we breathe. Carbon cycles, oxygen cycles. Energy flows from sun to plants to animals to atmosphere and back. Fire is just that cycle visible. Fire is the system showing you its mechanics. When you watch wood burn, you're watching stored sunlight escape. You're watching carbon return to carbon dioxide. You're watching oxygen reunite with its partner. You're watching time run backward as the tree unbakes itself, as structure collapses to gas, as order returns to entropy. The smoke rising is carbon particles that didn't fully react, tiny specks floating upward because they're hot and less dense than surrounding air. The ash remaining is minerals, the fraction of the tree that actually came from soil. Everything else, the carbon, the hydrogen, the oxygen, has become invisible, converted to carbon dioxide and water vapor. The mass didn't vanish, it transformed to gas and dispersed. If you captured every molecule of smoke and gas released by burning wood, it would weigh exactly the same as the original wood plus the oxygen consumed. Mass is conserved. It just changes form. Stellar physics. The conversion of mass to energy on scales that dwarf anything happening on Earth. That's hydrogen atoms being crushed together under unimaginable pressure until they fuse into helium, releasing the energy that powers stars. But I'll leave you there, because the beautiful thing about understanding is that answering one question always reveals 10 more. You started asking why fire burns. Now you understand it's about atomic barriers and chain reactions. But that leads to asking where wood comes from, which leads to photosynthesis, which leads to asking where oxygen came from, which leads to the history of Earth's atmosphere, which leads to asking what powers photosynthesis, which leads to the sun, which leads to asking what powers the sun, and on, each answer opening new doors, each insight revealing deeper connections. That's what Feynman understood. That's what he tried to show people. That the world isn't a collection of isolated facts. It's a web of interconnected processes, each depending on others, all flowing from fundamental principles. Fire connects to trees, connects to sunlight, connects to oxygen, connects to respiration, connects to evolution, connects to stellar fusion. Everything touches everything else. Pull one thread and the whole tapestry moves. So the next time you watch a candle burn, don't just see flame. See stored sunlight escaping. See carbon and oxygen finally reunited. See atoms that spent years held apart by a tree's patient work. See a chain reaction cascading through billions of molecular collisions per second. See time collapsed. See the sun shining again in a different form. See a small piece of the cosmic cycle made visible. Fire isn't just hot and bright. Fire is proof that you live in a universe where energy flows, matter transforms, and everything, absolutely everything, is connected.